Welcome back to this channel. In this video, we are going to discuss others tutorial question in this chapter. So in next video, we are going to discuss the objective questions. Without wasting the time, let's start. Okay, now we are in tutorial question number 6. Question A we already discussed in last video. So today we continue with the question B. With the aid of equation, state the reagent condition required to prepare A. So A is the product from 3-phenylpropanoic acid. Okay, so A is the product, and then we need to prepare from phenylpropanoic acid. Okay, as we know, propanoic acid consists of 3 carbon, so this one we label as carbon 1. So the carbon 3 will bonded to a benzene ring. When the benzene ring as the substitute, it will known as phenyl. So complete with the hydrogen CH2, CH2. Okay, then the next one we are going to do is from carboxylic acid to aldehyde. Basically, we know this is the reducing process. However, if the carboxylic acid undergo reduction with lithium aluminium hydride in dry ether followed by hydrolysis, due to the reducing agent, we have no differentiate to the strong and weak oxidizing agent. So once undergo reduction, definitely we are going to produce the alcohol. So we become primary alcohol, CH2, CH2, CH2OH. Okay, and then from the primary alcohol, if we want to produce aldehyde, then we are going to use weak oxidizing agent, PCC CH2Cl2. Okay, now is B from the 1-phenyl 2-propanol. So let's draw the structure propanol and 2-propanol, so OH is over here, phenyl is at the first carbon. Okay, so when we will complete this with H2, H and H3. So from this one is the secondary alcohol, and then this is the ketone. So I think we can have one step goes from secondary alcohol to ketone, which is through the process of oxidation. Therefore, we can use hot acidified KMnO4. Okay, last question, we need to from the B3C from benzene. Okay, so this is the product, so we start from the benzene. So when we look at the reactant and the product, we will notice that this is the part that supposedly will become from the reagent. So and then from here, basically we know the process of this reaction is Friedel-Crafts acylation. So if this is Friedel-Crafts acylation, so means that I will copy back this. The reagent is CH3, CH2, and then C double bond O. The reagent is acyl chloride, and where the bond is break between the carbon and the Cl. So and then don't forget we need the catalyst AlCl3. So for this one, only one step we can produce the C. So that's all for the question number 6. Okay, now let's proceed to tutorial question number 7. We look from the question, complete the reaction scheme. C4H9Br, once we can see the halogen, so we know P basically is the haloalkane. Okay, and then the haloalkane react with NaOH aqueous is undergo nucleophilic substitution, and where the bromine Br will be replaced with the OH. So the Q basically is the alcohol. So once the alcohol react with the KMnO4, H+, we know this is the oxidation process. So basically this is a carbonyl compound. So either is primary, will be the secondary, should be the ketone, because KMnO4 is strong oxidizing agent. So if this alcohol is a primary alcohol, so react with strong oxidizing agent, it will produce carboxylic acid. So therefore, from here we know that the Q is secondary alcohol. So if Q is secondary alcohol, the haloalkane definitely also will be the secondary haloalkane. Okay, because secondary alcohol react with strong oxidizing agent will produce ketone. And then this ketone react with I2 in NaOH. We know this is the iodoform test. So means that, and then have the yellow precipitate, means this is the positive result. So means that the R is the ketone with methyl carbonyl group. Okay, and then when react with the Brady reagent, we'll have orange precipitate. So again, we can double confirm that the R is the carbonyl group. Okay, besides using this, maybe sometimes you also can look at the general formula. For example, the PCnH2n plus 1Br. So this is the general formula for haloalkane. For the alcohol, CnH2n plus 2O. And then for the carbonyl compound, CnH2nO. Okay, so this is the difference. If it is alcohol, the hydrogen is 2n plus 2. But if it is carbonyl compound, only 2H2n. Okay, so now they ask us to predict identify the P, Q, R, S, and T. So maybe from here we can start to identify the structure R first, because this one consists of 4 carbon, and then they must have a methyl carbonyl group. So this is the methyl carbonyl, and then we complete with CH3, CH2. Okay, so and then from here maybe we can let the Q. So when the Q react, we know that it is secondary alcohol. So when we try to reverse back the ketone, let's say undergo reduction to produce the Q, which is the secondary alcohol, CH3, CH2, COH, H, and CH3. And then the P will be CH3, CH2, so the hydrogen maintain, the OH basically is replaced to the Br and CH3. So the S over here they are mentioned, it is the yellow precipitate, so it's CHI3. Okay, then I think we have no space for the structure T, so I will continue it in next slide. Okay, so now let's proceed with the structure T. So the just now R we already identified the structure R basically is butanol. Okay, and then going to react with the Brady's reagent, which is 2,4-dinitrophenylhydrazine. So H2N and H attached to the benzene ring, and then 2,4-dinitro. Okay, so as we already know, if this happens, carbonyl will taken out the O, and then the hydrogen will taken out the OH to produce H2O. Oh, sorry, we are not writing the equation, so we can ignore this H2O. But then we will write CH2, CH2, C double bond, and then CH3, I put it at the top here. Next, the double bond will connect it to the nitrogen H. Okay, so this is the orange precipitate T. Okay, proceed to tutorial question B. Compound W has the structural formula shown below. How would you convert P to W using the R? Okay, so now let's start with the P. P just now is secondary haloalkane. So we will going to have CH3 CH Br CH2 CH3. Okay, and then using the R is the butanol CH3 C double bond O CH2 CH3. Okay, so from here we know that haloalkane react with the carbonyl compound, and then the W is the alcohol because we can see there is OH group, and this alcohol is attached to 1 carbon, 2 carbon, 3 carbon is tertiary alcohol, and number of carbon also is combination of these two compounds. So means that this haloalkane need to be converted to Grignard reagent. Okay, magnesium in dry ether. Okay, haloalkane will become the sorry, I think I have to change the color first to the red color. CH3CH, so this one will become MgBr, and then CH2CH3. Okay, when they react with the butanol, okay, so this is when react with the butanol, CH3 C double bond O CH2 CH3, and then followed by hydrolysis. So we will start from here. CH3 C double bond O will become single bond, and then connected to CH2 CH3, and then this bond will bonded to this group, so carbon, and then bonded to hydrogen, CH3, sorry, maybe I make the hydrogen over here, and then over here will be the CH2 CH3. So then you can see hydrogen is over there, methyl over there, methyl group also, ethyl group also over there. So this part, the oxygen, since we'll undergo hydrolysis, so later the oxygen will attach to the hydrogen. So now we check the compound W with this one. So we have the carbon. Yes, we have the carbon. And then this carbon bonded to CH3. Yes, bonded to CH3. And then bonded to a carbon. Yes, this carbon. And then this carbon going to have CH3. Yes, over here. CH2, CH3. Yes, over here. Hydrogen. Yes, over here. And then CH2, CH3. Yes, over here. And lastly, the OH. Yes, over here. So we get the correct answer. Okay, continue with tutorial question number 8. Compound BC4H8 with the formula CnH2n. So basically, we will know this is the general formula for cycloalkane or alkene, which give only compound C, C2H4O after ozonolysis. So between the cycloalkane and alkene, definitely we know that alkene will undergo ozonolysis. So you can write down here, B is alkene because can undergo ozonolysis. Okay, then we continue. This compound C, C2H4O, CnH2nO, so is the carbonyl compound. Okay, was obtained after dehydration of compound A. So if we want to produce B from A with the general formula CnH2n plus 2O, so basically we know that the A is the alcohol. Okay, then now we will continue here. Compound DC4H8O is obtained after oxidation of A. Okay, so after alcohol undergo oxidation, So this is CnH2nO again. So it's the carbonyl compound. Okay, and then the reaction with hydroxyamine with the D. So hydroxyamine is NH2OH will give a solid E compound C4HN H9NO. So basically we know this is because we see that it's amine ammonia derivative, so we know this process is the condensation. So write the possible structural formula for each of the compound. Okay, so just now we already identified that B is the alkene, okay, because can undergo ozonolysis. So an alkene with 4 carbon, so it's either 1 butene or 2 butene. But because of ozonolysis of the B, will only give one type of product, which is C2H4O. So definitely, I think we will have the choice, know that the B is the 2 butene. Okay, so don't forget to complete with the hydrogen, CH2, CH, CH, sorry, CH3. Here is CH3. Okay. Okay, come, let's write CH3. Okay, so just now we say this is the B. Okay, so let's label. This is the B. Okay, then from here, because of B undergo ozonolysis, so the structure C will be CH3, CH double bond O. Okay, the carbonyl compound, and then the A is dehydration of alcohol. Dehydration of compound A is alcohol. So definitely we will going to know the alcohol is secondary alcohol. CH3, CH, CH2, CH3. And then this alcohol is secondary alcohol and then undergo oxidation, definitely will produce ketone. So will be CH3, C double bond O, CH2 and CH3. Okay, so and then this compound D going to react with the NH2OH. Okay, so as we know, the double bond O will be taken out. Okay, so we complete CH3, C double bond O will become single bond O, and then maintain the CH2, CH3. Sorry, the double bond O is still maintained, but we take out the oxygen because this is condensation process. And then for the hydroxyamine, we will taken out the H2, so we will connect nitrogen and then with the OH. So now if we check the formula, C4, 1, 2, 3, 4, done. H9, 3, 5, 8, 9. And then we have one N and one O. Yes, these are the answer for question number 8. Okay, let's continue with the last question, question number 9. And aldehyde A react with ethyl magnesium bromide, so which is CH3, CH2, MgBr, followed by acid hydrolysis to form a compound B, C7H16O. So from here, basically the general formula is CnH2n plus 2O. So we know that B is an alcohol. And due to A is the aldehyde, when aldehyde react with the green reagent and followed by the hydrolysis going to produce secondary alcohol. So treatment of B with concentrated sulfuric acid will give C7H14, CnH2n. So we know this is the alkene. So reaction of C with ozone followed by zinc in water, yield two product, propanol and butanol. Okay, identify the compound A through C. and then write the equation for each chemical reaction involved, suggest another greener reagent and the carbonyl compound, which also will going to produce B. Okay, so after we read this, so basically we know A is an aldehyde. Okay, when react with greener reagent, followed by hydrolysis, produce B, which is a secondary alcohol with the formula C7H16O. So we know that this secondary alcohol consists of 7 carbon, but there are 2 carbon is from the greener reagent. Therefore, the aldehyde will consist of 5 carbon. Okay, aldehyde consists of 5 carbon. And then this secondary alcohol, when undergo dehydration, remove the H2O, will going to produce an alkene. Then this alkene undergo ozonolysis, produce propanol, which consists of 3 carbon. And another one is butanol, which consists of 4 carbon. Okay, so from here we are able to, this one is C7H14. So from here we will able to identify the structure C. Okay, so this is the structure C. So by taking out the oxygen from the double bond, I can rearrange like this. Double bond O will be over here, and then this is CH3, and this is also another CH3. Okay, then for the butanol, I also rearrange so that the double bond O is over here, and then this is CH3 with CH2, CH3. So when I do this, then now I can erase the oxygen, and then I can bond them together, the double bond. So okay, so maybe I can rewrite again better. Okay, CH3, CH3 over here, double bond, CH3, CH2, and CH3. So this is the structure for C. 1, 2, 3, 4, 5. 2, 3 dimethyl, 2, 3 dimethyl, 2 pentene is the structure C. Okay, so in next slide we are going to discuss about the structure B and structure A. Yeah. Okay, now let's continue to predict the structure B, since we already predict the structure C. So now we can continue to predict the structure B. So as here B, we know that it is a secondary alcohol. Okay, so if we want to get the structure C, so we can refer to the structure, if we want to draw the structure B, we have to refer to the structure C over here. So basically, based on our understanding, because of B is alcohol, remove water dehydration to produce C. So basically, for the structure B, we have to add on the H and OH at the alkene. However, no matter, let's say I break the double bond, form 2 new single bond. No matter the OH is attached to the left-hand side, this one will become tertiary alcohol. Even though if I make the double bond over here is OH, and then this one is hydrogen, it is also will produce tertiary alcohol. So in other words to say, now we are going to produce a secondary alcohol, which means that actually this secondary alcohol, when undergo dehydration, there is rearrangement happen. Okay, never mind, but don't forget our purpose only want to identify the A through C. Okay, so if there is rearrangement happen. So there are two possibilities. So it means that the CH3 may rearrange to the left hand side. If this happens, so one will be hydrogen and then another one will be hydroxide. Continue with CH2, CH3. Another possibility is the CH3 is rearranged or shift to the right hand side. So here will be CH3, CH3, and then here since already rearranged, so here will be hydrogen and oxygen, and then CH2, CH3. So both these also is secondary alcohol. Okay, however, which one is the correct structure? So basically, don't forget that just now we already identified that A is an aldehyde consists of 5 carbon. Okay, so now we will roughly to get the idea. Okay, if we break the double bond, okay, the carbon here, okay, there must be 5 carbon and then another 2 carbon is from the ethyl magnesium bromide. So if let's say this part belongs to the OH part, the hydroxyl group here belongs to the aldehyde, so the new bond might be over here. So means if this happens, means that the Grignard reagent consists of 1 carbon only. However, if here this hydroxyl group is from the carbonyl, so here basically is from the Grignard reagent, okay, which consists of 2 carbon. So maybe some of you will say, possible it will be break down over here. Yes, definitely. So if you break down over here, so this means this Grignard reagent consists of 1, 2, 3, 4 carbon. So if it's brought by here, so the Grignard reagent consists 1, 2, 3, 4, 5 carbon. So from here, definitely we can confirm that the structure B is this. Okay, based on the previous slide, so we say that this part with the 2 carbon is from the Grignard reagent because the question says ethyl magnesium bromide. So that means the structure of aldehyde will have around here. So the functional group for the aldehyde is C double bond OH. So basically means that for this one, the structure A, we are going to maintain the alkyl group CH3, 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 and then bonded to C double bond OH. So when we check this carbon, there is 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon, and this is the aldehyde. This is the functional group for the aldehyde carbonyl. Okay, so after we complete the structure, so now we go to the next one. Write an equation for each chemical reaction involved. So that means we have to show A react with ethyl bromide and form B, one equation. And then second equation is the B react with the concentrated acid to give C, one equation. And the third equation is the C undergo ozonolysis to produce 2 products. So basically we need to write down 3 equations. Okay, since we already identified the structure A, so it will be easier for us to write down. So CH3, 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 and then C double bond OH react with the Grignard reagent CH3, CH2, MgBr, and then followed by the hydrolysis, H2O, H plus. So as usual, I will always start from the carbonyl compound, CH3, CH3 methane, and then C double bond O becomes single bond O, and then the H methane, so form two new single bond. So one single bond will get the methyl group, the alkyl group from the Grignard reagent, which will bonded to CH2, CH3, and due to undergo hydrolysis, so the oxygen, another bond is bonded to oxygen. Okay, then the next one, we are going to write the equation at where is the is the alcohol CH3, 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 and then COH. So maybe we can change here H over here. So this is CH2, CH3. And then going to concentrated sulfuric acid heat. So when this happens, basically at first we supposedly will remove the OH over here, and then it will become carbocation. So this carbocation is considered secondary carbocation. And then what going to happen is the CH3 over here and this carbocation, they will undergo rearrangement. Okay, so let's say after undergo rearrangement, so basically the carbocation will turn to CH3, CH3, and then this one is the positive charge, CH3, hydrogen, and CH2, CH3 to form tertiary carbocation, which is much more stable. Okay, so based on the mechanism, after the tertiary carbocation happen, we are going to remove the hydrogen. So there is two possibilities for us to remove the hydrogen. We either can remove the hydrogen from the first carbon at the left hand side, or the hydrogen from the right hand side here. Okay, so let's use different color. If we remove the hydrogen from the left hand side here, so the CH3 will become CH2, and then we will have double bond, CH3, CH3, maintain the hydrogen, and here will be CH2, CH3. Okay, if we remove the hydrogen from the green color, the carbon that we remark green color here, so the product is CH3, CH3, double bond, CH3 and CH2, CH3, which this is the structure for the C. So between these two, definitely the C is the major product, and the red color one here is minor product. So what is the rules that we follow? We are following the Say-Jeff rules, which telling us that the major product is the most stable and always with more alkyl group. Okay, so the structure with the green color here consists of 1, 2, 3, and 4 alkyl group, while the red color only consists of 2 alkyl group. Okay, let's continue with the last part of the question, at where you are going to suggest another Grignard reagent and carbonyl compound, which will also produce compound B. So this is the compound B that we draw just now. So just now we identified the right hand side here is from the Grignard reagent. So there are another possibility, means at where the left hand side here will be from the Grignard reagent. So if the left hand side here is from the Grignard reagent, so this will be Grignard reagent, which is CH3, 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 and then this one we're going to the bonded to MgCl, okay, or MgBr also accepted. And then another one is the carbonyl compound. So the carbonyl compound, so we just write back here CH, CH2, CH3, and then the OH will become double bond O. So both these Grignard reagent and the carbonyl compound, when undergo the similar process, also will going to produce this secondary alcohol. So I think we already finished discuss all the tutorial subjective questions in the tutorial. So in next video, we are going focus on the objective question only. Okay, see you in next video. Bye bye.